Albert Einstein is best known for relativity, but he also played a major role in the birth of quantum mechanics. In this video, we explore Einstein's life and his revolutionary ideas about light, energy, and the strange new physics that emerged at the beginning of the 20th century. Albert Einstein was born in Ulm, Germany in 1879. As a student, he often clashed with rigid teaching methods of his schools, preferring independent thought over memorization. Even as a young man, Einstein showed deep curiosity about nature, mathematics, and the hidden laws governing the universe. His habit of questioning accepted ideas would later help him transform modern physics. After graduating from college, Einstein had difficulty obtaining a university teaching position. He eventually found work at the Swiss Patent Office in Bern. While reviewing technical inventions during the day, Einstein spent his spare time thinking deeply about physics. Far from the major research universities, he developed many of his revolutionary ideas independently. At the end of the 19th century, many scientists believed physics was almost complete. Newton's laws explained motion, while Maxwell's equations described electricity, magnetism, and light. Yet certain experiments involving heat radiation and atomic behavior produced puzzling results that classical physics could not fully explain. A scientific crisis was beginning to emerge. In 1905, Einstein published 4 scientific papers that permanently changed physics. Historians now call this his miracle year. His papers explained Brownian motion, introduced special relativity, and explored the connection between mass and energy, and proposed a radical new idea about light. But one paper focused on a particular strange possibility that light itself might behave like a particle of energy. Einstein proposed that light behaves as if it consists of tiny packets of energy. Later scientists would call these packets photons. According to Einstein, higher frequency light carries more energy than lower frequency light. This idea directly challenged the long-established view that light was purely a wave. If Einstein was correct, then light behaved both like a wave and particle, something that challenged traditional physics. Many scientists consider Einstein's proposals radical and difficult to believe. Scientists had discovered that shining light on certain metals could eject electrons from the surface. This phenomenon became known as the photoelectric effect. Experiments showed that the color of the light mattered more than its brightness, something classical wave theory struggled to explain. Einstein's light quantum theory proved a simple and powerful explanation. Einstein's light quantum hypothesis faced strong resistance. For decades, experiments had shown that light behaved like a wave through interference and diffraction. Even Max Planck, whose own work helped inspire quantum theory, remained skeptical of Einstein's interpretation. Over time, however, new experiments increasingly supported the quantum view. In 1921, Albert Einstein received the Nobel Prize in Physics. Surprisingly, the award was given mainly for his explanation of the photoelectric effect, rather than for relativity. By this time, evidence supporting quantum theory had become difficult to ignore. Einstein's work had helped launch one of the greatest scientific revolutions in history. Einstein helped create the foundations of quantum mechanics, yet later became uncomfortable with some of the philosophical implications. He famously objected to the idea that nature was fundamentally based on probability, declaring that God does not play dice. Even so, Einstein's work on light and energy transformed modern science. Today, technologies such as lasers, solar cells, and electronics all depend on principles connected to quantum physics. Ideas that once seemed strange and controversial now help power the modern world. Thank you for watching.